Welcome back, guys. We're in chapter 3 and we're doing lesson 3.1, solving quadratic equations. Now I'm apologizing ahead of time. I do have a bit of a cold and I may be coughing a little bit, so just bear with me, but we will get through this video. Okay? All right. So we did quadratic functions in chapter 2. And now we're going to do quadratic equations. Basically the same thing, except we're looking for square root. We're looking for roots, zeros, solutions, whatever you want to call them, of these quadratic equations. So the way we can solve these quadratic equations, we have 3 ways. You can solve them by graphing. All right, so we can graph the function and then see where that function crosses the x-axis. And those points are going to be also known as your x-intercepts, but they're also the solutions to these quadratic functions. So we can graph, we can use square roots, and you're going to see that that method works for a very specific type of quadratic equation. It has to be missing the bx term, and we'll talk about that in a minute. So bx is missing. If that term is not there, then you can use the square roots method. And the third one is through factoring. All right, and that's why you received that factoring worksheet, because I wanted you to go back and revisit how to do factoring, all different types of factoring from Algebra 1. Okay, so let's begin with example 1. And we have graphing. Excuse me. So we have x squared minus x minus 6 equals 0. And we're asked to find the solutions to this equation using the graphing method. Okay? So we're going to go ahead and set up our xy plane here. And just like we did it as a function, remember, as a function, this looked like f of x equals x squared minus x minus 6. So we're just going to go ahead and solve this as if we did that, you know, just the same exact way. We're going to find the axis of symmetry. The only thing here is that the function is being set to 0, the value of the function. So we're looking for those zeros. So the axis of symmetry is going to be x equals negative b over 2a. Again, we're looking for this vertex. Okay, so this is going to be, b is negative 1, so that'll be a positive 1 over 2 times 1. So that's 1/2. So my axis of symmetry is x equals 1/2. That means my vertex is going to be at 1/2 comma something. Remember, the axis of symmetry, the vertex is always on the axis of symmetry. So we go back up to our equation and we're going to plug in 1/2 for x and see what it gives us. So wherever there's an x, you're going to put a 1/2. So 1/2 squared minus 1/2 minus 6. This is going to give me 1/4 minus 1/2 minus 6. Again, we want common denominator so we can add or subtract all of these. So this is going to be 1/4 minus 2/4 minus 24 over 4. Because remember, 24 divided by 4 is just 6. And this is going to give me negative 25 over 4. All right, so my vertex is at 1/2 negative 25 over 4. Okay, so let's go ahead and graph this. Okay, give me just a second. Okay, so by the way, this is just negative 6¼ all right? So we're going to go to 1/2. Let's see, here's 1, here's 2, here's 3. Let's make that 4, and here we've got 1, 2, 3, 4. All right, so the vertex is at 1/2. So again, this is, we're just going to kind of eyeball this. Just a second. This is going to be our axis of symmetry at positive 1/2, and then we're going to go down to negative 6¼ so 1, 2, 3, 4, 5, 6, and a smidge, so we'll go right around there. Now what we need are the x-intercepts, right? We obviously can see that this function here in that equation, they're going to open up because your a value is positive. So that means if the vertex is down here, that this is going to have to cross the x-axis at 2 places. So what we're going to do is we're going to find the x-intercepts of this particular function. Now remember, the x-intercepts are when y equals 0. It could also be f of x. It's the same thing. We tend to use y for in Algebra 1, and then we change it to function notation, f of x, but they represent exactly the same thing. So we're going to solve this. We're going to factor this and see what we get. So we've got x squared minus x minus 6 equals 0. We're going to go ahead and factor. The factors of x squared are x and x. Factors of 6 that when you either add or subtract them are going to give you -1. Well, that's going to be 3 and 2. 3 times 2 is 6. Now, the way you decide which one is negative, you look at the original. This is a minus here. So we look for the bigger of the two numbers, which happens to be 3. That means 3 has to take the minus sign, and the other one will have the plus sign. Okay? Again, if this was a positive up here, then 3 would be a positive. Whichever is the bigger number gets the sign of that term. All right, so we know that x plus 2 times x minus 3 is 0. That means either x plus 2 equals 0 or x minus 3 equals 0. And we just solve for x. So x equals -2, and here you have x equals 3. So these are known as your x-intercepts, which you know by now. But they're also called your roots. They're called your zeros. They're called solutions. Okay? So this was at -2 and 3, so we go up here, and we're graphing this, -1, -2, and 1, 2, 3, and we know that's our vertex. And again, this is kind of, sort of, as close as I can get without real graph paper, but that's what it looks like. All right, let's do another one. Go ahead and put this here so you can see it. We're going to go ahead and do another problem. This one will be problem B. All right, so here we have -2x squared minus 2 equals 4x. We're going to go ahead and move everything to the left. We're going to put it in standard form. So standard form of a quadratic, if you remember. Sorry about that. standard form of a quadratic is ax squared plus bx plus c equals 0. So we're going to want to move everything to the left and get 0 on the right. I am not sure why this is so dark. The screen is so dark today. I have a feeling there should be a light somewhere that's turned on, but it's not. I'm not going to play too much with this. Maybe I will. What could possibly go wrong, right? Well, that's not a good thing. All right, we'll leave it alone. I'll play with it for the next video. So let's go ahead then and subtract 4x from both sides. So we get negative 2x squared minus 4x minus 2 equals 0. And again, we need to find our vertex. But before we find our vertex, we must find our axis of symmetry. So axis of symmetry is x equals negative b over 2a. So that's going to be negative negative 4, which is a positive 4, over 2 times negative 2, which is 4 over negative 4, which is negative 1. So my axis of symmetry is x equals negative 1. Okay, that means my vertex must be at negative 1 something. And the way we figure out that something, that y value, is by plugging it back in here. So negative 2 times negative 1 squared minus 4 times negative 1 minus 2, we want to know what that is. Negative 1 squared is a positive 1 times negative 2, that's negative 2. Negative 4 times negative 1 is positive 4 minus 2. So that's going to give me 2 minus 2, which is 0. All right, so we know that we have a vertex at negative 1, 0, and that our axis of symmetry is at negative 1. Now, not only do we have a vertex at negative 1, 0, we also have our x-intercept. We only have one x-intercept. This is going to be one of those functions where it just touches the x-axis. So you're going to have something either like that, where it just touches at one point, or maybe there, something like that. One solution. All right. So we have our vertex, and because I said this is not only your vertex, this is also your x-intercept. And remember, another word for x-intercept is root, zeros, solutions, etc. That means that my solution is just negative 1. We only have one solution. So x equals negative 1, that's going to be our solution for this one. In order to graph the rest of it, what I would do is look up here and see what the y-intercept is. Remember, the y-intercept is when we let x be 0. So if we let x be 0, our y-intercept is at negative 2. So that means at 0, negative 1, negative 2, we have a point there. And because of the symmetry, that means that at negative 2, we also have a point at negative 2. So negative 2, negative 2, and you can go ahead and draw your equation, or your function there. Sorry. Okay, so that was the first way. We're going to go back here. You can solve them by graphing. So we just did that graphing part. The next way is to use square roots. And again, square roots are, this one you can use only when your bx term is missing. And let's explain what that means. So here's example 2. Let's say we have 4x squared minus 31 equals 49. Remember what standard form looks like. Standard form is ax squared plus bx plus c equals 0. If you notice, we have an x squared term right there, and these two are just constants. So we have a missing bx term. And that's the perfect situation or in order to use square roots. So what you do is you move your constants. I tend to move them all to the right side. So I'm going to add 31 to both sides. And I'll have my x squared term on the left. And on the right, 49 and 31, that's going to be 80. So this becomes really easy at this point. We divide both sides by 4. We are trying to isolate x, so we're going to cancel that. We're going to get x squared equals 20. And then we're going to take the square root of both sides. So super simple. That means x equals plus or minus the square root of 20. Now before you say you're done, just remember that whenever we do square roots, we do want them in simplest form. So while I don't recommend at all that you plug in square root of 20 and give me a crazy decimal, what I do want you to do is to separate this into perfect squares and not perfect square factors. So 20 has a factor that's a perfect square. It's 4. And 4 times 5 is 20. What is nice about this is we can simplify the square root of 4, and that is just 2. So this is really just plus minus 2 square root of 5. So once again, you still have two answers. You have x equals positive 2 square root of 5 and x equals negative 2 square root of 5. All right? Okay, let's do another one. So let's do part B. 3x squared plus 9 equals 0. Again, I'm going to move my constants to the right, so I'm going to subtract 9 from both sides. This is going to give me 3x squared equals negative 9. Now, my smarty pants students, you guys probably realize that this is something that can never be true, right? If we multiply something, if we square it, it's going to become positive. If it was negative originally, it will be positive, and if it was positive, it'll still be positive. And then you multiply that by a positive, and you have to get a positive. So this is never going to be a true statement. But let's go ahead and continue so that you see it, all right, so that you actually come to that conclusion. So I'm going to divide both sides by 3, and I have x squared equals negative 3. And now when I take the square root of both sides, I get x equals plus or minus the square root of negative 3. Now if you go in your calculator and type in the square root of negative 3, you're going to get an error. And the reason is the square root of negative 3, while we will deal with it very soon, for now we have to say that there is no real solution. It's actually an imaginary solution, but there is no real solution to this. So for us right now in lesson 3.1, now mind you, in a couple of lessons we will be able to work with this, but for right now, no real solution. So the square of a real number cannot be negative. The square, because the square of a real number, for example, x squared cannot be negative 3. Okay? And like I said, this is only for this lesson. Pretty soon we'll be able to play with these. But for right now, your answer would be no real solution, or no solution, whichever one you want. No, it's actually no real solution. There is a solution. So let's just say no real solution if the square root is negative. Okay? Moving on. Let's go to C. Here we have 2/5 x plus 3 squared equals 5. All right, in this case, we want to isolate this, obviously. So let's get rid of this 2/5. The way here right now, you're multiplying this side of the equation by 2/5. The opposite is to divide by 2/5 or multiply by 5/2 by multiplying by the reciprocal. So I'm going to multiply both sides of my equation by 5/2. That cancels that, that cancels that, and I'm left with x plus 3 squared equals 5 times 5 is 25/2. Remember, this is just a little 1 down there. You multiply numerator times numerator, denominator times denominator. At this point, we want this by itself. We don't want it squared, so we're going to take the square root of both sides, and this is going to give me x plus 3 equals square root of 25/2. And it's actually a plus minus, right? Now, we can simplify this. The square root of 25, you can break this into the square root of 25 over the square root of 2. That's perfectly allowable or legal. So if I have the square root of a over b, that's equal to the square root of a over the square root of b. So perfectly fine. And the square root of 25 happens to be a perfect square. It is 5. And we have square root of 2 in the denominator. We're still not done. We do not want square roots in the denominator. And you did this back in geometry and I'm sure algebra 1. We want to rationalize the denominator, so we're going to multiply by the square root of 2 over the square root of 2. Finish this on this side. This will give me plus minus 5 square root of 2 over, and then the square root of 2 over the times the square root of 2 is the square root of 4, which is just 2. We are almost there. Our last step is to subtract 3 from both sides. So we have x equals negative 3 plus or minus 5 square root of 2 over 2. Please note that the denominator of 2 only goes with this part. The negative 3 does not have a denominator. So you have two answers here. Again, you have either negative 3 plus 5 square root of 2 over 2 or negative 3 minus 5 square root of 2 over 2. Okay? All right, moving on. Okay, zero product property, which we've already touched upon. Basically says that if you have two numbers that you are multiplying together and you are getting an answer of 0, that means that one of the two numbers must have been 0. So if A and B are expressions, now they're actual values, that's all we really care about. If they're expressions or values, and when you multiply them together, that means when you multiply A times B, you get 0, then A is equal to 0 or B is equal to 0. All right? So really straightforward, very simple. Let's take a look at example 3. Here we are solving by factoring. So if you remember, we just did square roots, and now we are doing the third way by factoring. Okay? And this is where that worksheet comes really handy. All right, so let's say I give you solve x squared minus 4x equals 45, and I ask you to solve that by factoring. First thing you're going to do is you're going to move everything to the left. Okay, and we're going to get x squared minus 4x minus 45 equals 0. We put it in standard form, and we try to see if we can find factors. So factors of x squared are going to be x and x. Factors of 45 that will add or subtract and give you a 4 are going to be 9 and 5. Again, this is a negative 4x. That means the larger number, which is 9, will be negative, and the smaller number will be positive. And this, because of the zero product property, means that either x plus 5 is 0 or x minus 9 is 0. This means x is negative 5 or x is 9. Excuse me, guys, sorry. Okay, this is a little side note, x-intercepts. This was in your book, so I just want to make sure you know about it. X-intercepts, which we normally call P and Q, are also called zeros, and we've mentioned this already, zeros or solutions of the equation, right? Okay, moving on. Let's find the zeros of a quadratic function. So let's go over here. Example 4. We're almost done. Find the zeros of a quadratic function. So if you're given this function, f of x equals 2x squared minus 11x plus 12, and they ask you to find the zeros, you go ahead and let f of x be 0. So we're going to put it, we're actually going to move this to the right. It's easier to work with, I think. So I just flipped it around, but let f of x be 0, and then you're going to go ahead and factor this. You can factor this a couple of ways. You can do the guess and check method, which is the way I learned back in the day. Factors of 2x squared were 2x and x, and then factors of 12, that somehow gave you an 11, but you had to take into account that 2 that you have to multiply by. So those are going to be 4 and 3, because 2x times 4, that's 8x, and 3 times x, that's 3x. So 8x plus 3x is negative 11x, and then a negative 3 times a negative 4 is a 12. Again, you check this by using FOIL. So this is just guess and check. There is a different way. You take the 2x squared. You will still get the same answer. You're going to scoot this over here and multiply by the 12. So this is going to give you x squared minus 11x plus 24 equals 0. You're going to factor this. Again, we took the 2 and we multiplied by the 12, by the constant out there. This is going to give us x and x. Factors of 24 that give us 11. It's going to be 8 and 3, and these are both negative. But just like we multiplied by 2, now we have to divide each of these guys by 2. All right, and make sure they're in lowest terms, 3 over 2, and then you swing the 2 back to the front. So this becomes 2x minus 3, and this is 8 divided by 2, which is 4. So either way, you're going to get the same answer, and the choice is obviously yours, whichever way you prefer. Now, we still don't have our final answer, but we do have our factors. This means that either 2x minus 3 is 0 or x minus 4 is 0. So here we have x equals 4. And over here, we're going to add 3 to both sides, so 2x equals 3. That means x equals 3 halves. So once again, you are going to get the same answer either way. All right, guys, I'll see you next video. We'll do 3.2.